Let's talk about AI coding assistants. I mean, they're getting unbelievably powerful, right? They can spit out thousands of lines of code in just a few seconds. But here's the question. What happens when that incredible speed creates systems that are so complex, so opaque, that no human on your team can actually understand them? Today, we're going to dive into how to use all this power without, accidentally building tomorrow's tech disasters. Okay, so this right here, this is the heart of the problem. We've walked into this really weird era of, let's call it AI cost asymmetry. On one hand, the cost for an AI to generate code is just plummeting. I mean, it's getting close to zero. But on the other hand, the cost for a human engineer to understand that code, to validate it, to maintain it, that's skyrocketing. And that giant gap between those two lines, well, that's where things get dangerous. This crazy imbalance creates a brand new kind of technical debt. People are starting to call it cognitive debt. And it's basically the hidden price you pay when your team starts shipping code way faster than they can actually comprehend it. It feels like progress, like you're moving at light speed, but what you're really doing is burying yourself in a massive problem that you just can't see. Yet. And all that cognitive debt leads you right into something called the black box trap. This is what happens when you let it all pile up. You end up with these systems that, yeah, they look perfect in a demo, but they're a complete mystery to the very people who are supposed to keep them up and running. So let's break down exactly how this trap springs shut. So first, there's the human side of this. When an AI drops a pull request with thousands of lines of code, our engineers are basically forced to become reverse compilers. They're trying to figure out the why from a mountain of syntax. And get this, the data is pretty stark. Research shows a developer's ability to actually understand what's going on drops by half, 50%, once a code review gets bigger than 400 lines. So what happens? We stop checking for deep architectural problems and we just check for typos. And slowly but surely, the team completely loses the mental map of how their own system works. And you know what's wild? It's not just a human problem. The AI itself gets lost. These AI agents, they have a limited context window. They can only see a tiny piece of the code base at any given moment. So it might write perfectly correct, beautiful code in one file, but it has no idea that it's completely violating a core architectural principle that was set up 10 files away. This contextual drift creates this slow, creeping chaos that just rots your system's design from the inside out. So what happens when these black box systems built on a mountain of this invisible cognitive debt actually go live? Well, they turn into what we call day zero legacy systems. They're basically legacy code from the second they're deployed. And the failures, oh, they are not small. The first big warning sign is something called the test illusion. See, the AI will happily write a whole bunch of tests for its own code. Your dashboards will light up green, showing over 85% test coverage. You feel great, but it's a trap. When you run more advanced tests, like mutation tests, the kind that check if your tests actually catch real bugs, that score just plummets. We're talking less than 15%. So yeah, the lights are green, but they're not actually testing anything that matters. And then you hit the production chasm. A critical P1 incident happens, system down. Your team's playbook says a fix for this kind of thing should take, say, 45 minutes. But nobody has that mental model of this system anymore. They have to reverse engineer the AI's logic from scratch, all while the house is on fire. And that 45-minute fix, it suddenly balloons into a 72-hour all-hands-on-deck crisis. And that brings us to the final awful stage, cascading failure. Under real-world pressure, some tiny hidden bug, maybe a memory leak the AI just kind of hallucinated into existence, causes latency and memory usage to spike by over 500%. It's like a silent time bomb that doesn't just crash the new service, it takes the entire system down with it. Okay, so after hearing all of that, you might be thinking, is this even worth it? Should we just ditch these AI tools and go back to writing everything by hand? It really feels like you're stuck between two bad options. The old, slow way, or this new, dangerously fast black box. But the good news is, the answer isn't to reject the tech. It's about finding that smart path in the middle. We don't have to choose between the black box and slow manual coding. We can build a glass box. So the glass box, it's really an engineering philosophy. It's all about building systems that take full advantage of the incredible speed of AI, but within a framework that guarantees they stay observable, resilient, and, this is the most important part, maintainable by actual human beings. Let's just put them side by side, because the contrast is everything. The black box is opaque, it's brittle, and it's super high risk. The glass box, on the other hand, is designed from the ground up to be observable, resilient, and maintainable. We're making a conscious trade. We're trading a little bit of that raw, unchecked speed for long-term stability. So the big question is, how do we actually build one of these? Well, it all comes down to a simple blueprint, one that's built on 4 key principles. And it's all about shifting the human's job from being a code janitor to being the system's architect. It all kicks off with these 4 ideas. First, we break down the problem strategically. Second, we set up automated deterministic guardrails. Third, we progressively harden the system by baking in observability. And last, but definitely not least, we contain the blast radius of any potential failure. So what does this look like in the real world? Well, for decomposition, you make the AI act like an architect first. Have it generate diagrams and API contracts that a human has to approve before a single line of code gets written. For guardrails, your automated pipeline just flat out rejects any code that's too complex. And for hardening, you make a simple rule. The AI is not allowed to write a function without also writing the code to log and trace everything it does. Now, this 4th principle, blast radius containment. This one is so clever. It often uses a method called the Strangler Fig protocol. So instead of doing a risky rip and replace, you deploy the new AI-generated service right next to the old one. Then you route a tiny percentage of real, live production traffic to it, but as read-only shadow traffic. This is how you can safely test a potentially dangerous black box in the real world. You can compare its outputs to the old system's output and see how it behaves under real pressure, all without any risk to your actual users. It's a game changer. When you step back and look at the big picture, all of this really comes down to a fundamental shift in how we think about these AI tools. They're not just faster keyboards, they're a totally new kind of thing in our workflow. See, the old view, the dangerous one, is to treat the AI like a compiler, this perfect, infallible tool that gets it right every single time. The new view, the safer and much more effective one, is to see the AI as a bounded agent. It's incredibly powerful, sure, but it's also probabilistic. It needs clear, solid boundaries designed by humans to operate safely. We don't ask it to build the whole house, we ask it to make perfect bricks, while we stay the architect. And so that really leaves us with one final question, something for you to take back to your team. As these amazing tools get more and more woven into our daily work, it is absolutely worth asking, what are you building? Are you chasing speed no matter the cost and accidentally creating an opaque black box? Or are you consciously engineering a transparent glass box, one that's built to last? The choice you make is going to define the future of your systems.